Welcome to the deep dive. Today, we're going underground to explore the world of caves.
And what better inspiration than a listener's recent trip to the Phra That Cave in Thailand?
Right. They wrote in about their adventure near those Erawan falls. First, a pretty intense hike, right?
Yes, quite the workout to reach the cave
They
entrance.
said like 30 minutes straight up these steep steps,
Oh,
but then this narrow little opening and boom, you're inside.
that moment of discovery, right?
Totally. Suddenly this massive cavern, like over 200 meters across, just breathtaking.
That contrast really sets the stage for the experience.
It does. And inside, all these incredible formations, stalactites hanging down, stalagmites coming up from the ground.
A classic cave scene.
Exactly. Some even look like a Buddha, they said. Plus, formations like coral reefs, just stunning.
Nature's artistry on full display,
And this peaceful, almost quiet atmosphere with bats flitting around overhead.
adding a touch of mystery to it all.
Yeah, so we thought, perfect time to do a deep dive into how these incredible caves form.
A perfect choice. We'll cover the types of caves, how they develop, their unique features, and even the life they support.
So strap in, everyone, because we're going deep underground to unravel the mysteries of caves. First things first, how does nature even create these underground landscapes?
Well, it's all about those powerful geological forces working over incredibly long periods, millions of years we're talking.
Millions of years, wow.
And there are four key processes: weathering, erosion, dissolution, and sedimentation. These are the sculptors of the underground world.
Okay, so weathering. That sounds like the rock breaking down, right?
Yeah, think of it as the disintegration of rock, either physically or chemically.
Okay, give us some examples.
Sure, like when water seeps into cracks in a rock, it freezes, expands, and forces the rock apart.
Like on those steps up to the cave, maybe?
Yeah.
Freeze-thaw cycles, right?
Exactly. That's physical weathering. And then there's chemical weathering, where minerals in the rock react with things like oxygen, weakening its structure.
So weathering creates the first openings, the weak spots.
Right, the vulnerabilities that the other processes can then exploit.
Got it. Then comes erosion, and this is where water really comes into play, right? Like carving a canyon.
You got it. Erosion is wearing away the rock. Think of water flowing over the surface carrying tiny bits of sediment.
Yeah, like sandpaper, I guess.
Exactly. Those particles act like abrasives, slowly scraping and scouring away at the rock, widening those cracks, turning them into passages.
So the cave starts to take shape. But what about those formations? It seems like something is being built, not just worn away.
You're right, and that's where dissolution comes in. This is especially important for caves formed in limestone, like Phra That Cave.
Limestone, that's a key ingredient here.
It is. Limestone is mainly calcium carbonate, which is soluble. Rainwater, as it falls through the air and soil, picks up carbon dioxide and becomes slightly acidic.
So we've got weak acid, essentially.
Right, and this slightly acidic water can dissolve the calcium carbonate in the rock. Over time, those dissolved spaces grow into larger cavities, eventually forming the cave systems we see.
So the water's not just wearing the rock down, it's dissolving it away.
Precisely. It's like a slow, patient sculptor. And then we have sedimentation, the building part.
Okay, explain sedimentation.
Well, as water flows through a cave, it carries dissolved minerals and tiny rock particles. When the water slows down or evaporates, it can't hold those materials anymore.
So they get left behind.
Exactly. And that's how those amazing cave formations, like stalactites and stalagmites, are built up.
So it's a continuous cycle of breaking down and building up, all thanks to water.
It's a beautiful dance between destruction and creation, playing out over millions of years.
It's mind-boggling. Okay, so we've got the basics of how caves form. But you mentioned different kinds of caves. Not all caves are created equal, right?
You're right, there are different types, each with its own unique formation story. Generally, we group them into four main types: solution caves, lava caves, sea caves, and glacier caves.
Okay, solution caves, those are the limestone ones we've been talking about, right?
Yeah. Yes, also known as karst caves. Karst is a specific type of landscape, often with sinkholes and underground drainage systems.
Sinkholes, those are scary.
They can be. Basically, the ground collapses into those cavities, created by dissolving limestone. It's all interconnected.
Wow, so that cave with its limestone and formations is a classic solution cave in a karst region.
Exactly. And then we have these fascinating lava caves.
Lava caves. Sounds a bit more intense.
They form during volcanic eruptions. Imagine molten lava flowing like a river. The outer layer cools and hardens, forming a crust, but underneath, the lava keeps flowing.
Like a tunnel of fire.
Yes, Eventually, the eruption stops, the lava drains away, and you're left with a hollow tube, the lava cave.
Wow, that's incredible.
You can find amazing lava caves in places like Hawaii and Iceland.
Okay, what about sea caves? Those sound a bit closer to home.
They are. Sea caves are carved out by the power of ocean waves.
Just the constant pounding of the waves.
Right. Over time, the waves, especially with sand and pebbles, erode the weaker parts of the rock, creating hollows that can become caves.
You see them on coastlines like California, right?
Absolutely. But exploring sea caves can be risky because of the tides and unpredictable waves.
Yeah, definitely not for the faint of heart. Okay, last but not least, glacier caves. Caves made of ice. That sounds temporary.
They are. They form within glaciers as the ice melts and refreezes. Water flows through the glacier, carving out these incredible formations like ice stalactites and stalagmites.
Wow, so there are ice formations too.
Absolutely. You find them in places like Alaska and Switzerland. But yeah, glacier caves are tied to the life of the glacier. As the glacier melts and shifts, the caves can disappear.
So we have this incredible variety of caves, each shaped by its own forces. But let's go back to those solution caves for a bit. You mentioned they form in stages.
Right. The birth of a solution cave is a long, slow process. We can break it down into 3 stages: the initial stage, the enlargement stage, and the decoration stage.
Let's take them one by one. The initial stage, this is where the very first hints of a cave appear.
Exactly. Imagine that slightly acidic rainwater we talked about seeping down through the soil and reaching the bedrock.
Slowly trickling down.
Right. Over thousands of years, it exploits tiny cracks in the rock, dissolving the limestone bit by bit, creating tiny openings.
So thousands of years just for the first tiny cracks.
It's a long game. Then comes the enlargement stage.
Okay, so the cave starts to grow bigger.
Yes, with more openings, more water can flow through, increasing the dissolving power. The water widens those passages, creating more space for even more water to flow.
Like a feedback loop.
It is. More water, more dissolving, bigger cave. And finally, we reach the decoration stage, the most visually stunning part.
This is where we get those amazing formations.
Exactly. It's all about the deposition of minerals. As the water drips, flows, or evaporates, it leaves behind those dissolved minerals, building up over time.
Creating those speleothems you mentioned earlier.
Precisely. Those stalactites, stalagmites, flowstones, and all the rest.
Okay, let's dive deeper into those. Stalactites, those are the ones hanging down like icicles, right?
That's right. It's all about water dripping from the ceiling. Each drop hangs for a moment, and as it evaporates, a tiny bit of mineral is left behind. Over time, those tiny deposits build up, creating the stalactite, growing downwards, drop by drop.
And stalagmites are the opposite, growing up from the floor.
Yes, formed by drips hitting the floor. The water spreads out a bit, evaporates, and leaves behind minerals that build up into those cone shapes.
And if they grow long enough, they can meet in the middle, forming a column.
You got it. A stalactite and stalagmite meet and fuse, creating a pillar from floor to ceiling.
So majestic. You also mentioned flowstones. Those sound like frozen waterfalls.
They can look like that. They form when water flows over the cave walls or floor. As it flows, it deposits thin layers of minerals, creating those smooth, often wavy shapes.
And the colors can be amazing, right?
Absolutely. Depending on the minerals in the water, you can get all sorts of colors.
Wow, so much variety. And lastly, those delicate straws.
Those are formed by water dripping through a tiny hole in the ceiling. Each drop leaves a tiny mineral ring, and over time, those rings build up into a thin, hollow tube.
So fragile. It's amazing they survive at all.
It is. They're easily broken, which is why many caves have protections in place.
It's mind-blowing to think about all these formations happening in complete darkness over millions of years. But caves aren't just about geology, are they? There's life down there too.
That's right. Caves are unique ecosystems, and the geology plays a big role in shaping them. It defines the boundaries, how energy and nutrients flow, and the conditions for life.
So even in the darkness, there's a whole world thriving.
Absolutely. We call these cave-dwelling organisms cave biota, and they have adapted to the challenges of this environment in fascinating ways.
Like what kind of challenges?
Well, think about it. Perpetual darkness, limited food sources, and the need to navigate in a three-dimensional world without sight.
Sounds tough.
It is. And we categorize these creatures based on how dependent they are on the cave environment. We have troglobites, troglophiles, and trogloxenes.
Okay, break those down for us.
Troglobites are the true cave dwellers. They can only survive in caves and have developed very specific adaptations.
Like what?
Well, many lack pigmentation, since there's no need for camouflage in the dark. They often have enhanced senses like longer antennae or sensitive hairs to help them navigate and find food.
So they've traded sight for other senses.
Exactly. Then we have troglophiles. They can live in caves, but they can also survive outside in similar, dark, humid environments.
Like a best of both worlds situation.
Right. And finally, there are the trogloxenes, the cave visitors. They use caves for shelter or roosting, but they can't complete their entire life cycle there.
Like the bats we talked about earlier.
Perfect example. They use caves during the day, but fly out at night to feed.
So we've got these specialized cave dwellers, creatures comfortable both in and out of caves, and then the visitors just passing through.
That's a great way to summarize it, and it's amazing to see how life has adapted to these challenging, unique environments.
It is. Okay, so we've covered a lot of ground today. Let's recap some of the key takeaways from our deep dive into the world of caves.
Let's do it.
We started with our listeners' trip to the amazing Phra That Cave in Thailand.
A great place to start our journey.
And we talked about the geological processes that shape caves, those powerful forces of weathering, erosion, dissolution, and sedimentation, working over millions of years.
A slow and steady transformation.
Then we explored the different types of caves: solution caves, lava caves, sea caves, and glacier caves.
Each with its own story of formation.
We delved into the 3 stages of solution cave formation, leading to those incredible formations: stalactites, stalagmites, columns, flowstones, and straws.
Nature sculptures hidden underground.
And finally, we ventured into the world of cave ecosystems, with those fascinating cave biota and their incredible adaptations to life in the dark.
A reminder that life finds a way, even in the most unexpected places.
Exactly. So hopefully, our listener now has a deeper appreciation for the wonders of Phra That Cave and the vast geological processes that shaped it.
And maybe a newfound curiosity for all the hidden worlds beneath our feet.
Absolutely. So here's a thought to leave you with. If water can carve out these incredible underground landscapes over millions of years, what other seemingly solid landscapes around us are being transformed right now, even if we can't see it happening?
It's a reminder that the Earth is constantly changing, shaping, and reshaping itself over time.
A humbling thought indeed. Thanks for joining us on this deep dive into the world of caves.
Until next time.